All right, you go
So
ahead.
my topic for today's presentation is energy storage technologies, application to the renewable energy source grid integration. So I have the following contents. So starting from the introduction, then I try to overview about energy storage technologies, then overall comparison of energy storage technology also covered under subtopic 3. Then result and discussion of the paper also highlighted under subtopic 4. Finally, I will present the conclusion portion. So let's start from the introduction portion. So as you all know that there are different types of renewable energy sources, including the biomass, wind, hydropower, geothermal, and solar. So currently, the generation capacity of these renewable energy sources are increasing with high rate. If you take the International Renewable Energy Agency data from IRENA 2019, the generation capacity of renewable energy source is around 2,537 gigawatt. So it is increasing from year to year. So out of this total generation capacity, the hydropower renewable energy is taking the largest share of the global total. Next to hydropower, the wind energy is the next higher generation capacity from the renewable energy. But the thing is here, as you all know, that the renewable energy have a problem of their generation capacity is not consistent. That means they are intermittent in their nature. So for instance, if you take the wind energy and solar energy, whenever they can generate energy whenever there is a wind speed and a solar radiance. So this is the problem of renewable energy. So to mitigate this problem, there are different options, but currently different researchers are going to mitigate this problem by using energy storage technologies. So our research is focused on this topic. The first one is defining or assessing the major energy technologies that are available in commercial level. Then the next step is how these energy storage technologies can be technically, economically, and environmentally fit to be evaluated. So this is our aim of our research. So to overview the energy storage technologies, so we can classify these energy storage technologies based on their applications area as well as based on their form of stored energy. So when we classify them according to their form of stored energy, there are around 6 energy storage types, starting from the mechanical, electrical, thermochemical, thermal, and chemical, and electrochemical also one of the type of energy storage technology. So this type of energy storage technology, some of them are matured type of energy technology, the rest are underproven and almost under development stage. And especially when you come to, for instance, the mechanical energy storage technology, the pumped hydro storage technology is more matured and its installed capacity is high compared to others. And when you come to the electrochemical types, lead acid also almost mature technology and its installed capacity globally also high. But if you take the lithium ion, it's competitive and currently such type of energy storage also highly installed over globally. So we try to identify first, our methodology is selecting these energy storage technology types. So as I told you, as I presented in the previous slide, there's different energy storage technologies. So among those different energy storage technologies, we select 11 energy storage technology types based on their availability of their characteristics data in literature works. So among those different energy storage technology, we select the following. The pumped hydro storage is one of our energy storage selection type. Compressed air energy storage, Vrije, supercapacitor, supermagnetic energy, lead acid, nickel cadmium, sodium sulfur, sodium nickel chloride, lithium ion, and flow battery types is our selected type of energy storage technologies based on their availability of their performance characteristics. So this energy storage compared using the following criteria. The first one is the technical criteria, such as the power range, energy density, efficiency, discharge time, response time, lifetime, self-discharge, and technology maturity level is one of the criteria to compare and contrast which energy storage is suitable for renewable energy source grid integration application case. The other criteria is the economic criteria. Among the economic criteria, we select the capital and operating cost of energy storage technologies. The last one is based on their environmental criteria. So the environmental impact of energy storage technology is one of our criteria for comparison and selection of these energy storage technologies. So based on these characteristics or criteria, we compare the selected energy storage. As I presented, 11 energy storage technologies are selected. Then we compare in terms of these criteria. Let's start from the energy and the power density of energy storage comparison result. So as you see from the slide, compared to all selected energy storage technologies, the electrochemical energy storage systems have higher energy density than others. If you see, for instance, specifically the lithium ion, it consists both high energy density and power density. So such characteristics, it indicates that such type of energy storage technology have application potential to the grid level, because in grid level, it needs such type of characteristics, especially the energy density and power densities. If one energy storage technology have high energy density, means it can store energy for long periods. So such type of energy storage is applicable in grid connection level. So as I said, lithium ion is best suited for grid level because of this and another characteristics of the energy storage types. When we come to the power density, as you see from the slide again, the flywheel energy storage and supercapacitor energy storage, supermagnetic energy storage have high power density than others. So having high power density means, in other way, their discharge time is almost low, but such type of energy storage technology is applicable especially for power quality applications and intermittence balancing. So this is the comparison in terms of energy and power density of the selected energy storage technologies. So the second one is the power rating and discharge time of energy storage comparison results. So as you see from the graph, the compressed air energy storage and pumped hydro storage type have higher power range and high discharge times. And contrary, if you see the supercapacitor and flywheel and supermagnetic energy storage, they have small power range and a small amount of discharge time. So if we categorize such type of energy storage according to these characteristics, we can categorize the pumped hydro storage and compressed air energy storage under energy management because they have high power range and they can stay for long discharge time, hours to days. To contrast, in other way, if you take these other energy storage types, specifically the supercapacitor energy storage and fuels, they have similarly small amount of power range and almost low discharge times in seconds. So again, such type of energy storage is also applicable for power quality applications. And they can also be used for intermittent smoothing purpose. So the third one is the daily self-discharge time of energy storage comparison results. So as you see from the graph, again, among the other energy storage types, the flywheel energy storage types have high self-discharge time, almost around 75%. And when you come to pumped hydro storage and compressed air, the flow battery types almost they have negligible energy daily self-discharge times. So this by itself have some indication. So for instance, if you take fluid energy storage, if such type of energy storage stay for 1 day, they can dissipate their stored energy within 1 day. So this is the side effect of fluid energy storage. So they can't stay for a long time once they stored this energy capacity. So when you come to the chemical energy storage types, the sodium sulfur and sodium nickel chloride have high self-discharge times. For instance, sodium sulfur have 20% of self-discharge time, and sodium nickel chloride have almost 90.07 self-discharge time. And similarly, for electrical type of energy storage, when you compare to others, supercapacitor and supermagnetic energy storage also have high daily self-discharge times. So in terms of when you compare in terms of their lifetime, again, the mechanical energy storage types, specifically the pumped hydro storage types, have high lifetime, almost around 15 years. So when you compare to others, for instance, electrochemical energy storage have less lifetime compared to others, almost within the range of 7.5 up to 15 years. So the other comparison is based on their technology maturity level. So as I said, out of the selected energy storage types, the mechanical energy storage types, so-called the pumped hydro storage, have the matured one, and from electrochemical, lead acid and nickel cadmium also have the matured and fully commercialized type of energy storage compared to others. But the rest, they are under proven and commercializing technology. So they're underdeveloped. Some of are well developed, but they need some research and development stage. But these three types of energy storage, including the pumped hydro storage, lead acid and nickel cadmium batteries, are almost fully matured and fully commercialized. And the sixth one is their efficiency, the round trip efficiency of energy storage. So compared to all selected energy storage, as you see from the graph, the Vrije and supercapacitor and supermagnetic energy storage have, including the lithium-ion batteries, have high cycle efficiency, almost above 19%. But the rest, they can under the range of 74.5 up to 90%. So the Vrije and supercapacitor and supermagnetic and lithium-ion have high energy or cycle efficiency. So the seventh one is the response time. Again, compared to all selected energy storage types, the Vrije and supercapacitor and supermagnetic energy storage have fast response time in milliseconds. And when you come to the electrochemical, the response time is in terms of seconds. But when we come to the mechanical energy storage, the so-called the pumped hydro and compressed air energy storage have their response time is in minutes. So the eighth comparison selecting criteria is the energy capital cost and power capital cost. So as you see from the graph, again, compared to all selected energy storage technology types, the capital cost per kilowatt hour of pumped hydro storage and compressed air storage types are almost have low range category. And on the contrary, the fuel energy storage and supercapacitor and supermagnetic energy storage have higher capital cost per kilowatt hour. So if you compare among electrochemical energy storage, nickel cadmium and lithium ion and sodium sulfur have higher capital cost per kilowatt hour than other rechargeable batteries. And the ninth selection criteria for comparison is the environmental impact of energy storage. So as you see from the graph again, among all selected energy storage technologies, the pumped hydro and compressed air energy storage and all electrochemical energy storage have high impact to the environment, but the fuel and supercapacitor energy storage have very low impact on the environment. So finally, we have summarized the result and discussion portion here. Based on the comparison results, the study shows that the following 8 points. The first one is, as I discussed before, electrochemical energy storage system have high energy density than others. So such type of energy storage have been used for energy management applications, since if they have high energy density, they can stay for long duration. So such type of energy storage type is selected for grid integration purpose also. The second one is the pumped hydro storage and compressed air energy storage have higher power range and longer discharge time than others. I already discussed this. The third point is summarization is the pumped hydro storage and compressed air energy and the flow battery types have a very small or negligible daily self-discharge time than others. And the fourth one, pumped hydro storage and compressed air energy storage have longer life than others. And the fifth summarization is pumped hydro storage and lead acid, nickel, cadmium battery are the most mature technologies than others. And the sixth one, fuel energy storage, supercapacitor, and supermagnetic energy storage and lithium-ion batteries have very high round-trip efficiency than others. The seventh, pumped hydro storage and compressed air energy storage have the lowest capital cost per kilowatt hour than others. Finally, fuel energy storage and supercapacitor have a very low environmental impact than others. So our conclusion, we conclude in such a way. We found commercially available energy storage, but no single storage system meets the requirement of all renewable energy source constraints. So this means renewable energy sources have different constraints. So to overcome these constraints, if we select single energy storage, that single energy storage maybe not overcome the problem of renewable energy source. So this is our finding. So the other conclusion is an energy storage system can be suited for specific application in renewable energy sector based on their characteristics of the renewable energy source as well as the energy storage technology. So to select the exact suited type of energy storage technology, we have to study first the characteristics of the application area as well as the energy storage technology. So by doing this, we can select the exact suited type or the appropriate type of energy technology for grid resource, renewable resource for grid integration applications. So our review shows that a high potential application for lithium-ion batteries, and it is most fit to mitigate the fluctuation issue of renewable energy and utility grid integration sector. So lithium-ion, based on different characteristics, it's fit for renewable energy source for grid integration application based on different, as I discussed on the previous slides. If you compare to others, lithium-ion have best suited for such type of renewable energy source for grid integration applications. But the thing is, the cost of lithium-ion battery currently is high. So this is a problem of lithium-ion battery, but in other characteristics, it's fit for renewable energy source for grid integration applications. So if the cost is reduced, such type of battery is typically fit for renewable energy grid integration application. So this is all about for my presentation. So if you have any questions, you're welcome.